This presentation is an example of the use of the gra005 tool to create code architecture to import a text file. This is the second of 4 presentations. It's crucial to have any understanding of this current presentation. You really need to go through the introduction if you have not done so already. And so we're going to assume that you have seen that. And in this presentation, we're going to be taking text files which happen to have CPT information. And that information is in a format that can't be natively read by Gint. So this tool will, the gra005 import addin option, will set up the code architecture so that you can read those files. And then your code would extract the data, create a temporary Gint CSV file, and then a script is run to do the import. And we're calling this direct text file import because we're going to be using the final Gint project structure as the target. There are cases, which we'll see in the last presentation, where you may not know what the final structure is. In that case, we're going to be doing a mapped export or import, which is where we create a structure, just a generic Gint CSV structure with your own table and field names based on a data dictionary that you create. The user would then need to create a correspondence file to map between the two. And in the next presentation, we'll be doing the same things we're doing now with text files, but with Excel files. Now, in all these 3 import examples, we're just basically mimicking the 3 projects we already have on our website, gra001, 9, and 11. These already do the imports, and they were rewritten with this new tool. So it's the same code architecture. All right, let's take a look. So in the introduction, we set this all up. We've got all of our code ready to go. And we've opened up the project structure that we're going to be writing to. And this is taken from gra001. And it's just a simple database structure. It just has point table and CPT table. That's it. What we're going to be importing from are files that look like this. And so before you do any of this, you have to decide how you're going to map this. Well, we've decided not to map anything from the first line. We could have put stuff in. It all depends what it means. This is such a sparsely documented structure, you would have to ask the manufacturer what these things mean. We've decided to just map this. We're going to call that the borehole name. We're ignoring the rest. And then in the data lines, this happens to be depth, tip resistance, and sleeve friction. These are pore pressure measurements, and we're not going to bring those in. So we're just going to bring this in. So we're going to be taking this file and converting it into a CSV structure, a Gint CSV structure with table names, field names, data, table name, field name, data. And we're going to have, for just 2 tables, the point table and the CPT table. All right, so we're going to run the add-in, code skeleton generator, the import add-in. And we went through this in the introduction. So we're going to call this procedure import CPT, written by me, import CPT data into Git. You can get more detailed, of course, and you can always edit this after we've written the rule. And we're going to use the current project as the target structure. We don't need a correspondence file. And in an enterprise database, we can't allow importing into a new project in the database because we don't have project information. So we're not going to mark that either. And file description, we'll call them CPT files. And the extension, and we only have one here, CPD. If you happen to know that all your CPD files are in one folder, put that in here so it saves the user the trouble of navigating every time. And we're going to allow multiple selections, so we can import more than one file at a time. So we're going to import the CPT and the point table. In the CPT table, we're going to import all of this. In the point table, just point ID and holdup. We don't have any of the other information. And we're done. It's now in the Windows clipboard. And we're going to go to Game Rules, Add-ins, go here, and we're going to paste. And save. All right, let's talk about this. There are actually two procedures. The main procedure, you don't have to do a thing with. It's all written for you. You may want to change the description, more detail, but this is the way all of the import routines that we're going to show you now work. There will be differences based on your configuration settings. But the main thing is it's going to be building a script. And the script says we're going to be doing an input operation, we're going to import text. The project is, well, we don't know what the project is yet. This is a constant. This never changes. So we have to put in a replaceable parameter, which is defined up here. And this text can be anything you want as long as it's unique. And then it wants to know the data file. Well, we don't know what the data file is. The code architecture that we've pasted in is going to create a temporary CSV file and pass that back to you in this procedure. And then we're going to replace this with that file name. And then the override option, we're going to be prompting the user for the override option here. And then we're going to replace whatever the user picked in this position. And then finally, it's going to delete the temporary CSV file. So that's our base. We said we wouldn't allow importing into a new enterprise project, and this is that test. It first checks, is the current database enterprise? If the answer is yes, if the enterprise current project ID is 0, Gant assigns a unique number, which you don't see, it's off screen, to every project within an enterprise database. When you're on that empty line in the project table, in a SQL Server database, that project ID is 0. And then this message will come up. And then we're done. We exit. You have to put focus on a project, a specific project that already exists for this role to run. And then the file dialog, where it's prompting the user for the files. And here's the multi-selection option. And then a dialog comes up for showing the different override options. And if you don't have not worked with override options before in import, it's the same override options you would get in file, import, export, import from text, or any of these others. And to learn about that, go into help and search for override options. If you decide you want to hard code a specific override option, you can just delete this code here and then replace this line with one of these options here. And then the user won't see that dialog. Then it calls the second procedure. This is a procedure where all the work, real hard work takes place, where the files, the source files are read, parsed, and then the data written to this temporary Gint CSV file. We pass in the source list, which is obtained from the file dialog. It returns a list of files the user selected. And this procedure then returns the name of that temporary file that was created. This is a function. It returns either true or false. And notice the name, it failed. So if true is returned, something went wrong in the procedure, and it returned a true, and then we're done. We go to exit here, and we don't process any further. And it's the responsibility of this conversion utility to put up the appropriate error messages. So if we've made it past this point, we have a valid import file, and we're now doing these replaceable parameters. Remember, in the base script, we had these three replaceable parameters: the import file name, the current project name, and the override option. So here's where we're doing the replacement. We're replacing the project with the current database. This is a procedure that we merged in the setup. You could, instead of writing this, you could write git roles dot current project dot name. That will return the current project name. However, it doesn't work properly with Enterprise. With an Enterprise database, all it returns is the database name. For Access projects, it will return the full path and name of the file, which is what we need. But for Enterprise, it doesn't return enough information. So this procedure was written to return the appropriate naming for Enterprise and Access. It'll work for both. And for Enterprise, it also passes back the user-defined project identifier for that project. We're going to need that later, if it's an Enterprise database. If it's an Access database, this comes back empty. And then we replace the import file placeholder with the actual name of the import file, and then the override option placeholder with the actual override option. And if it is an Enterprise database, this will come back with a value, and then we have to add one more line to the script for Enterprise import to specify what specific project we're importing into. And then we run the script, and it's done. So let's get to the real work here. So this is the procedure that does most of the work. And again, this tool has set up a lot of code for you. What it's done, for every table, it's creating a temporary file and writing the header information that Git needs for each section. It's going to put a star table name. Don't put that here. It'll put it in the procedure. And the list of fields. Now, the list of fields you see here are the list that you see in input in that same order. The order is totally unimportant. You can put point ID at the end if you wanted to. What's crucial is that the order of this list must match the order that you build the data lines down lower. When you're reading the files and writing the data back to these temporary files, you better write the point ID in the first position and the depth in the second position, etc. They've got to match, otherwise you're going to get garbage in. And then it returns, this is just an arbitrary name, it's just a unique identifier for the temporary file, and the tool just puts 1, 2, 3, as many as tables as you have. You could rename those if you like. Then it returns the name of the file it created and a handle of the file. It leaves the file open so we can start writing to it, and this is the file handle so we can write to it. Okay, that's all taken care of. Then it takes a source list, the list of files that were selected, and splits them and puts them into a vector, a one-dimensional array. And then it walks this vector from 1 to the number of files that were selected. It then, for each file, it opens that file and extracts all the data into one variable called sdata, and then closes the file. We're done with that file. Then it splits the data into another one-dimensional array, a vector, one line per line in the file. And then we walk every line. And then we assign the data for the current line into a variable, and you do your magic here. And then we go to the next line, and then to the next file. We'll come back to this part in a moment. And then when that's all done, you close the file, close the two files here, and then we create this temporary file using this unique file name, which is one of those other required procedures that we brought in during the setup presentation. And we open it and we call this procedure twice, once for each table. And again, this is one of those procedures that we copied in. And you pass in the name of the table file and the handle to this temporary file we've created. And it will merge the contents of this file into this final, again, CSV file, as many as there are. So this is all done for you. We close the temporary file. We pass back false as failed, but did not fail. Where you would find failure conditions, perhaps, is in this code that you're writing. As you're parsing the file, you may find something that is fatal. You can't proceed. You would then put up a message. You would set this variable to true, and then you would exit function. And then the caller would see that something bad happened and would terminate any further processing. Okay, I am not going to spend the time rebuilding this for you. It's already been done, and that is in gra001, which is what I'm going to bring up in a moment. The last step, as we talked about in the introduction in this process, after you write this, after you write this, you then go in under Gint Rules, Add-ins Manager, and you add a new menu command that would reference this code. So I'm going to call this CPT import, description, imports, blah, blah, blah. You got the idea. The command line label, we're going to call it CPT import. No submenu. We could have a, let's do that. We'll have a menu called import, and we'll put this underneath it. And you might have a CPT import, you might have a sieve import, you might have it, et cetera, et cetera. And the applications, we only want to run this in input. And finally, which code module do we execute when the user clicks on this menu item? So it's under Add-ins, import CPT, click OK, and we do want to require save. That would be the last step. If you had that core code written. At this point, your new procedure shows up. If we run it, we're going to get an error because there's nothing there to run. So what we're going to do now is switch to the final code, which is gra001. I'm going to change library. And let's take a look at the Git rules code. All of this is pretty much the same. gra001 does more than just import. It also previews the log when it's done, or logs, however many CPTs were imported. But structurally, this is exactly the same as what we looked at earlier. One thing I like to do when I'm setting up import procedures is to actually, at least with ASCII files, at least show the header section of the file in the documentation, in the description. Okay, so getting back to this file structure, as the notes say here, we're ignoring the first line, we're only reading this from the second line, and then all the data lines, depth, tip resistance, and sleeve friction. So up to here, it's exactly the same as what we saw earlier. This point down, this is the actual parsing code. It's not a lot, but it's interesting. So we're walking through all the lines, and we're asking, what line are we on? Are we on line 1? Well, we're not using it, do nothing, just keep moving. Now, we could have said from line 2 to number of lines and skip this case completely. don't like that, then the question remains, why did you do that? Why did you start at line 2? You could put a note up there. This makes it crystal clear what's going on. Further, you may decide you want to use line 1, and you're going to have to parse that differently. Okay. Otherwise, if it's not line 1, we do want the data, we're going to split the line on a space. This is one of these procedures that we merged in during the setup process. And so both these lines, the second line and the third and beyond, are delimited by spaces. And we don't care how many spaces, just spaces. And this procedure handles that. So what it returns is a one-dimensional array again, a vector, of all the data on that line as a separate element in the vector. If we're on line 2, we just need the first element, and that's your point ID. And this part here is necessary, the building the point list is necessary for when the remaining code does the preview of the log. So this is not part of the actual data import. Otherwise, if it's not line 2, it's a data line. And again, we've got a very nice feature here, the limited line make. We're putting it together into a CSV format. The separator is a comma, and then you put in what fields you're going to be storing in the order you want to store them. Remember, this order has got to equal this order, or you're in trouble. Now, we could have written this line ourselves. We don't need a function for this. It's really straightforward. You would just do something like this. Say, let's just copy this. S point ID, ampersand, comma, etc. S data v, blah, 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 blah. And you just keep doing that. You just keep concatenating stuff together. That'll work. Number one, it's a bit of a pain. There's a lot of typing going on there. The other thing is this deals with CSV rules. Now, in this case, you don't have to worry about that. The exceptions to CSV, what if you have a comma embedded in a field, or a quote embedded in a field, or a carriage return embedded in a field? This routine knows what to do and returns you a valid CSV line. So just in general, use this, and you never have to worry about that. Also, another little thing, we could have put sdata 1, sdata 2, sdata 3 instead of putting in these constants. Seems like a lot of extra work for nothing. But again, from a readability standpoint, an understandability standpoint, putting a 1, 2, and 3, you'd have to, so that people understand later that it's reading the code, you'd have to put, hey, 1 is equal to this and 2 is equal to that. Instead, just make a constant. And then it's crystal clear what each of these things mean. And the other thing, if the boreholes don't exist, then that we're importing the CPTs into, we have to create those boreholes. And Git requires a hole depth. So we're recording the maximum depth. Since all the CPT files always go down to the maximum depth at the bottom, we're just recording all of them on every row. And the last one we record will be the maximum depth. Okay. So that parses the file, and it writes it, the CPT data, appropriately to the file, to the appropriate file. Remember the file handles we got up earlier. Then, after we're done with the file, we ask, does the borehole exist? And again, this is one of those procedures we merged in from gra005. And if it doesn't exist, we want to write to the point file the point ID and the maximum depth. If it does exist, don't write that record. And then we loop to the next file. And from this point down, it's what we talked about earlier. It's done. So this was all it took. You didn't have to worry about any of this other stuff. So let's see how this works. So add-ins, gra001, import CPT. We pick the CPT files. Pick them both. And we're off to the races. It's going to do the import and do the preview. And then when we exit, we get the import log. You can suppress this, and so I refer you to command scripting and help. There are things you can put in the script to say suppress this. I don't recommend it because if there are any problems, it would show up here. All right, very good. Now, that was all nice. That was fully working, had been tested completely, but the chances of you getting it right the first time are pretty small. I don't think that's ever happened with me. There are always little things. Now, to debug those problems, what I recommend you do, we're going to go back into Git rules code here. And the program, this tool creates 3 sets of temporary files that it deletes when it's done. And what messed up would probably be very clear if you could see what was in those temporary files. And we can suppress the deletion of those files. So there are 3 sets. And they are in the script here, operation delete file. And I have already set this up to suppress this. I've remarked it. I've put a remark there, the apostrophe, a remark there, and a remark there. So this didn't happen on this run. Normally it would. When the tool is finished, this would have been active. To disable it, you mark these points here. The second set here is the actual script. Here, this parameter, this true or false parameter, by default it's true. The tool builds it as true. True says to delete the script, this temporary script, when you're done. False says don't. So that's already in here. And the third set are those individual table files that we built, that we merged into the final CSV file. This argument is not required. Let's put that in again. The argument is delete temp file. If you leave it off, it's true. It is deleted. But we had put in false. So they were not deleted. So those files are there. Where are they is the question. Well, the program puts all temporary files in the temporary, at least this code architecture, we set it up to put it into whatever you specified as your temporary files folder. If you don't know where that is, go under File, System Properties, and on my system, it is right here. I'm going to copy that, and I'm going to go to Windows Explorer and go to that folder, and then sort by date modified. And these are the files we're interested in. So let's take a look at the log file. That's what we saw earlier. This temporary file is the point data. So that's what it wrote. If there is a problem, you could easily see what the problem is here, and then you could change your code to fix that. And there is the CPT data, and it's got all the CPT data, CPT1, and there's CPT2. This is the combined one. So it's got the CPT data for both 1 and 2, and at the end it's got the point data. The order is not important on the CSV. Actually, it's not important in any source file. We don't care about table order. And then also it wrote the temporary script. Do not double click on it. It will run the script. Instead, I'm just going to open it with Notepad. And there's the temporary script that got written. It replaced the project with the current project, the data file with this temporary file that was set up, and then the override option. There we go. That's all. So recommend that strongly when you're doing these initially. So just to review, you want to rem out the operation to delete the temporary file. You want to change this true to false so it doesn't delete the script. And you want to put a third parameter as false so it doesn't delete the temporary table files. All right. And that covers that option. And the next presentation will be on doing the same thing, but with an Excel files for the source. Thank you.